Hi, Noel Chemist, Miss Rose here. I'm going to do a big review session on atomic structure and hopefully set you up to be ready to take the very first focus area in chemistry called atomic structure and to begin research on your chosen adopted molecule where you'll be using this information. Okay, first thing I want to do is take you to the whiteboard. And this whiteboard here that I've got going on here is to show you how to draw an atom and the different parts of an atom and where they go and how to decide how many there are of each different part of the atom. So if I could just draw your attention to nitrogen here. Nitrogen's symbol is N. Its atomic number is 7 and its atomic mass is 14.007. So I'm just going to tell you the smaller number is always the atomic number, and that is equal to the number of protons. So here we have it. Protons are positive, and they're found in the nucleus, and they're the same number as the smaller number. Protons really define an atom. If an atom has 7 protons, it's nitrogen. If it doesn't have 7 protons, it cannot be nitrogen. And if it has 8 protons, it's oxygen. If it has 6, it's carbon. We see that when we look at the periodic table. There is absolutely no way for nitrogen to not have 7 protons. Protons define the atom. Okay? So I know right away when I see nitrogen, it's 7 protons in the nucleus. And if I have 7 protons, then I have 7 electrons because I have the same number of positive and negative because I'm making this a neutral atom. So if I have 7 protons, I'll put them in the nucleus. I'm going to have 7 electrons. Now, electrons go in the electron cloud, and they go in electron shells or orbits around the nucleus. In the very first shell, closest to the nucleus, there can be up to 2 electrons. 1, 2. Now, I know that because I have 7 protons, I need 7 electrons. So the first shell only allows me to have 2. I need 5 more in the second shell. So I need a second shell. And I start by putting 1 in the north, 1 in the south, 1 in the east, 1 in the west. That still only gives me 6. I need 1 more because I need 7. So I go back up to the north. Okay. This second ring and every ring thereafter can hold up to 8. So there's space here for an additional 1 and here and here. And this is nitrogen. Okay? Now, how did I find the number of neutrons? Well, here I'm going to take the bigger number, 14.007, and round it to the nearest whole number. So that means I go to the decimal place and I go to the spot right beyond the decimal place. And if that's a 5 or above, I make this the next number. But since this is 0, I stick with the number 14. I subtract from that number my atomic number or my proton number. And this gives me my neutron number. Okay? Protons are always equal to the atomic number. And then electrons are always equal to protons. And neutrons are calculated this way. Go to the larger number, round it to the nearest whole number, subtract the number of protons, and here is your number of neutrons. Okay? So now let's answer a few questions. Let's see how we do. Okay? I'm going to go to a prepared slide deck. And let's go all the way back if we can. Here we go. review questions on atomic structure. The first thing you really need to know is what particles make up an atom, what are their charges, how much do they weigh, what is their mass, and where are they located. So let's start with the proton. We know the proton is a +1 charge. We know that it has 1 atomic mass unit mass, and we know that it's located in the nucleus. The neutron has no charge. It's neutral, but it has mass. It's 1 AMU, and it's also located in the nucleus. The electrons, as we know, are in the electron cloud in shells around the nucleus. They have a negative charge, and they have no mass. So the nucleus has the heavy pieces, right? It has the protons and the neutrons, the denser, heavier pieces. It's positively charged, the nucleus, because it has the protons and the neutrons, which have no charge. The protons are positive. The electron cloud around the outside is negative. And the reason the electrons don't just spin out is that attraction between the positive dense nucleus and the negative electron cloud keeps that atom together. Most of the mass, as we see, is in that nucleus, okay? So here we're going to take a look at something, okay? Here is the nucleus. That's our inner circle here. We've got the protons, which are number 4, and we've got the neutrons, which are number 3 here as labeled. And then the electrons will be in these electron shells. So the number of protons is the atomic number, the smaller number that you'll see on the periodic table. And the number of electrons equals the number of protons. And the number of neutrons is the atomic weight, or that bigger number, rounded to the nearest whole number minus the atomic number. Okay. And we did that with nitrogen, and we'll do it again. And then the atomic mass is protons plus neutrons. That's another thing we need to remember. So let's take a look again at what we did here with the nitrogen, right? We took this smaller number, it became our proton number. If we have 7 protons, we have 7 electrons. We need to put them in shells. Electrons go outside the nucleus, 2 in the first shell, 5 in the second shell. 1, 2, 3, 4, 5. And the 2 inside, 6, 7. And then to find the number of neutrons, we have to take the larger number, the atomic weight, round it to the nearest whole number. Here would be 14. Subtract 7 from that and get 7. Okay? And we did that with nitrogen. Just a quick review. The smaller number is the atomic number. It's the number of protons or positive subatomic particles in the nucleus. The number of protons is equal to the number of electrons, which live in the electron shells outside. They're negative. The number of neutrons has to be calculated. So you take the bigger number, the atomic number, round it to the nearest whole number. In the case of nitrogen, 14.007 becomes 14. Now subtract the number of protons from it to find the number of neutrons. There you go. And don't forget this equation as well. Atomic mass is protons plus neutrons. Atomic mass is basically the mass of the nucleus of an atom. Okay, so let's ask ourselves some questions. Which particles are found in the nucleus of an atom? Select all that apply. I'm going to give you a chance to look at this. Which subatomic particles are in that nucleus? Answer: neutrons and protons. Electrons are orbiting around outside. An ion is a positively charged particle. That's a compound or molecule. And a prion is from virology. Gold atoms can be identified based on the number of which subatomic particle? Give you a chance to think about this. I mentioned earlier the way we know something is nitrogen is by the number of, the answer is protons. That smaller number in the periodic table is the number of protons. Nitrogen has 7. If you are a nitrogen atom, you have 7. If you don't have 7, you are not a nitrogen atom. Next question. A certain atom has 20 electrons, 21 neutrons, 20 protons. What is the atomic mass? Well, the atomic mass is the mass of that nucleus. What's in that nucleus? 21 neutrons and 20 protons. So the answer is 41. Electrons are on the outside and they weigh almost nothing. So when I say atomic mass, I mean the mass of the nucleus of that atom. That's where all the weight is. Okay. And here we have it. This is a fluorine atom, and I know it's a fluorine atom because it has 9 protons. And if you go to the periodic table and you look for the element that has the small number 9, that is fluorine. 6 is carbon, 7 is nitrogen, 8 is oxygen, 9 is fluorine. Every single fluorine atom has 9 protons. If you don't have 9 protons, you're not fluorine. You're something else, but you're not fluorine. So what is the mass of this atom? Well, mass is, again, atomic mass is the weight of the nucleus, because these electrons buzzing around do not have any weight. So it's the nucleus, the 9 protons and 10 neutrons is going to be 19. Okay? Just a comment here, 9 protons, positive. So we know that we have 9 electrons, 2 in the first ring, and then 3, 4, 5, 6, 7, 8, 9. We have room for one more because we can fit 8 in the second ring. Okay, how many neutrons are present in this element? Okay. I don't know if you remember how to find neutrons, but you're going to take this bigger number, which is the atomic mass, and subtract from it the smaller number, which is the number of protons. And so we're going to get 23 minus 11 is 12. Okay. Neutrons is always going to be atomic weight, or the bigger number, minus the atomic mass. Sometimes in this focus area and in chemistry in general, you might see this written like this, where the bottom number here is the number of protons and the top number is the atomic mass, or the number of the weight of the entire nucleus. Okay, what is true about all atoms of oxygen? Let me give you a few seconds to read this over. I want you to think about what I said about what defines an oxygen atom. What defines an oxygen atom? What defines any atom? Number of protons. Good for you if you got it. So every single oxygen atom has 8 protons. There you go. The identity of an element is based on the number of protons. An atom has 5 neutrons, 2 electrons, and 4 protons. What type of atom is it? Well, let me just do something for you here. You're never going to guess this. You're never going to just guess it outright. You have to pull up a periodic table. So let me pull up my periodic table. Let me see if you can see this. Because maybe you can't. Do you see this periodic table? I think you do. So we're looking for something that has 4 protons. Beryllium. Let's go back to looking at our. Okay. 5 neutrons. I don't care. 2 electrons. I don't care. 4 protons. Protons define the atom. They tell me what kind of atom this is. This is beryllium. Okay? Another very similar question. An atom has 24 protons, 20 electrons, 28 neutrons. What type of atom is it? Which one of these subatomic particles are more important when we're trying to find the identity of an atom? You're right, protons. So let's look at our periodic table and find out which element has 24 protons. I don't know if you can see it there, but it's chromium. Okay, chromium. All right, so we're going to shift a little bit away from talking about the atom, how to model the atom, and protons, neutrons, electrons, and how to calculate neutrons, and how to calculate the mass of that nucleus, to talk about how did we discover what we know about the atom. Well, first of all, John Dalton was very key in explaining or postulating something we call the atomic theory. Now, John Dalton didn't have it completely right, but he had a lot of it right. Everything is made up of small particles called atoms. But he said that atoms were indivisible, which means they cannot be divided. And we know now that they can be. We can divide them into protons, neutrons, and electrons. We can get smaller than the atom. We can get subatomic. And we can even get smaller than those particles. But for the sake of this class, we don't need to do that. But John Dalton was the first one to say everything is made up of atoms. So J.J. Thomson then discovered the electron, began to think about, can we divide the atom? And he discovered this electron with something called a cathode ray experiment, and where he ran a gas through a small tube and basically created that neon gas you see in signs that say exit and things like that. Understood that it's the movement of electrons in that tube that actually gave off that light of fluorescence. So J.J. Thomson, electron. When I say J.J. Thomson, you say electron. There could be a question or two on this, on Dalton's atomic theory and everything being made up of atoms, and on Thomson discovering the electron, which is the part of the atom that's negatively charged and buzzing around the nucleus. And then Ernest Rutherford was the one who discovered that most of the mass was in that nucleus. We talk about how neutrons and protons are in the nucleus and how they're heavy. And so he was the one who discovered that most of the mass is there in that very dense small nucleus, because the protons and neutrons are there. And he also discovered that the nucleus was positive. And we know it's positive because protons are in there and protons are positive. But Rutherford was the first one. He used an atom of gold and basically shot positive and negative charges at it and saw the way when a positive charge came towards the nucleus, it deflected away because like charges repel. So he knew that if a positive charge was moving away from the nucleus, was being repelled by the nucleus, then the nucleus must be positive, and the nucleus was heavy. So that is everything. That's pretty much what you need to know to take this very first focus area for chemistry. Now, let's just return to Chrome for a second here. Oh, let me see if I can get this. So that we can begin to, let me see now if I can get it to share. So we can take a look at checkpoint number 2 and the very first activity. So the first thing you're going to do is watch this video, which you're watching right now, and good for you. The second thing you're going to do is complete the diagnostic assessment on the atomic structure focus area. For those of you who are new to focus areas, diagnostic assessments allow you to take almost like a pre-test or a practice test and get an idea of the things you need to know in order to sit down and take this assessment. If you do well on that assessment and you've reviewed these slides and you've been looking through the checkpoint number 1, I think, and some of the resources that I have listed up here, you are most likely ready to go ahead and take this assessment. So when you're ready to take the assessment, you need to text me because I unlock the assessment for you. It is a 10-question, usually mostly multiple choice, maybe some fill in the blank, but it is a 10-question, largely multiple choice objective exam. And you need to get 8 questions out of 10 correct. You can take it as many times as you need to, but I would encourage you not to take it until you're really ready, until you feel very comfortable with the type of questions I have in the review question slide deck. And the slide deck will be linked here for you so that you can look at those slides again. You're going to need a periodic table to do this. And again, this particular periodic table works, but any periodic table works. And often they'll provide a periodic table in the question. They'll have the question in the periodic table right off to the side, okay? But just to draw your attention to a few questions we answered in that slide deck, chromium does indeed have 24 protons. We know the smaller number here is the number of protons in the nucleus, and it defines the atom. So we see aluminum has 13, and phosphorus has 15, and magnesium has 12 protons in the nucleus. And if it has 12 protons, you know it has 12 electrons buzzing around outside in those shells. 2 in the first shell and 8 in every other shell. Okay? And we find the number of neutrons by taking this larger number, rounding it to the nearest whole number, subtracting the smaller number from it, and boom, that gives us our neutrons. And if we are looking for the atomic mass or weight, we know that's mostly in the nucleus, and we know the nucleus consists of protons and neutrons, so we add those together, okay? Guys, I want to tell you that chemistry can be a complex subject, and it's very hard to talk about the atom, to model the atom, and to calculate the subatomic particles of the atom virtually over Zoom and far away from each other. So I really, really hope that I see you guys in live class this week, but I'm always available to you through text, through email, through office hours. Let's really try to move ourselves through these two checkpoints and through this first focus area so that we can really start to begin to research our adopted molecules, okay? Thank you guys. Best of luck. Have a great day.